Namaste everyone. Welcome to second PUC physics class. So today we will discuss some problems in alternating current, which is very important. Namaste, welcome to the class. Hope you are doing well. The problems in alternating current are very important as well as theory. Either 5 marks theory or problem is a assured one for the final exam, and even in the entrance examinations you can work out problems here because you will have some backup from current electricity, which helps a lot to work out problems in alternating current. Only except some phase difference and all, whereas you don't have phase differences in current electricity. Here we have some phase difference that has to be taken into account. Now, instead of rewinding all the formulas once, we will jump into a problem wherein you will have to calculate everything. A series resonance circuit, resonant frequency, impedance, current, inductive reactance, capacitive reactance, and power factor, power dissipated, everything, even quality factor, everything. We will calculate everything in that. We will take such a problem. So we have the problem here. So here is the problem. First one, a source of alternating EMF, 200 volt and 500 hertz, 50 hertz is connected in series with a resistance of 200 ohm, an inductance of 100 millihenry, and a capacitance of 30 microfarad. Calculate the inductive reactance, capacitive reactance, impedance, current in the circuit, voltage across L, C and R, power factor, phase difference, resonance frequency, power dissipated, everything, quality factor. Does the current lead or lag? The EMF. What is the, which is leading and which is lagging, that's all. So, shall we start it one by one so that it helps you to remind all the formulas also. So, we will start from here one by one. So, we have one resistance, inductance and capacitance, all the three values, and 200 volt 50 hertz AC also. Okay. So, we will list the values first. We will start from here. That voltage is nothing is mentioned in that. A source of alternating EMF 200 volt 50 hertz. What do you mean by that? That voltage is RMS. If it is not mentioned, it is RMS. If it has to be peak, they should have mentioned it. Of peak value 200 volt. So if it is not mentioned, definitely it is RMS value. So because it is the equivalent DC value, isn't it? So 200 volt RMS, and so VRMS is 200 volt. What else? Frequency nu is equal to 50 hertz. Yes. Then what else? Hope you can see this, right? And resistance 100 ohm, right? 200 ohm. R is equal to 200 ohm. Then inductance, self-inductance 100 millihenry. 100 millihenry. Capacitance, it is 30 microfarad. Yes. So we will start from inductive capacitive reactance. What is the inductive reactance? XL is equal to omega L is equal to 2 pi nu L. So what the frequency they have given here may not be the resonant frequency, because you may set any frequency in the source, right? Number of cycles per second may be set any value, but need not be only a resonant frequency. So this may be at some other frequencies, either greater than resonant frequency or lesser than resonant frequency, or maybe even at resonant frequency, don't know. So we will calculate XL omega L. 2 pi nu L, XL is equal to 2 pi nu, that is 50 hertz. Inductance is 100 millihenry, 100 into 10 to the power minus 3. We will finish it within this line. Okay, that is better. 100 millihenry, yeah. Yes, that is equal to XL is equal to. Always remember, if frequency of AC is 50 hertz, you have an advantage here. 2 pi nu will be 314, because 2 into 50 is 100. 100 into 3.14 is 314. Only if this is 50, otherwise it is not possible. Into, this is 10 to the power minus 1, right? 10 to the power 2 here, and 10 to the power minus 3. 10 to the power minus 1, that is equal to 31.4 ohm, right? We have got XL. XL is 31.4 ohm. What is XC? XC is equal to 1 by 2 pi nu C. Is equal to, oh, you take a pen and paper and start it, okay? Don't look into the way in which you have solved it, right? This is not a dance program and one person is dancing here and talking to you and you are just listening. Not like that. You are not judging me. You have to learn yourself. Take a pen and paper, keep on working it out along with me. Then only you will understand, otherwise you will never understand it. Okay, 1 by 2 pi nu C, 1 by 2 pi nu C. C is 30 microfarad 30 into 10 to the power minus 6. Okay, xc. So if I am a little bit faster, you can pause it and you can wait for me, or wait you can wait till your calculation is over. So this I will take it as 314 again, because 2 into 50 is 100, 100 into 3.14 is 314 into 30 into 10 to the power minus 6. That is equal to into 10 to the power 6, because this will come to the numerator. So it is into 10 to the power 6. Remaining calculation, 1 divided by 314 and 1 divided by 30. 1 divided by 314 is equal to divided by 30, isn't it? 30 microfarad, yes. It is 0.000106. So shall I give 10 to the power 6 here? So I'll write the answer here. Xc is equal to 0.000 3 zeros 10615 into 10 to the power 6, because this comes to the numerator and becomes 10 to the power 6. Xc is equal to 123456, right? 106.15 ohm, because Xc and XL are measured in ohm. So inductive reactance and capacitive reactance are obtained. You see here, capacitive reactance is more than inductive reactance. Capacitive reactance is only 106.15. Let me check it once again. 1 by 2 pi nu c, c is 30 microfarad, correct? So 1 by 2 pi nu c is 314, okay, 1 divided by 314 divided by 30 is equal to, so 1, 2, 3, 4, 5, 6, that is 6, 106.15 ohm. Since Xc is greater than XL, what conclusion you can make? Capacitive reactance is greater than inductive reactance. It should be below the resonant frequency, right? Whatever you have the frequency for which the current is maximum, it should be below the resonant frequency. Current will not be maximum now. So below the resonant frequency means this is not resonant frequency. 50 Hz is below the resonant frequency. Resonant frequency will be greater than 50 Hz. So since Xc is greater than XL, because here we get frequency in the denominator. So since X is greater than XL, we can conclude that current leads, right? I leads V. Current should be leading. So by how much angle? That we have to find out. Tan phi you can use, or cos phi you can. But better use cos phi. Why? Because once you calculate cos phi, you have many advantages. You have found out power factor, and from the cos phi itself, you can find out phase angle. So two things can be done simultaneously. If you find out tan phi, it is not a power factor, right? So what I can do, yeah, Z I can calculate. Z is equal to root of R square plus Xc minus XL whole square. Z is equal to root of R square. What is the resistance value? 200 ohm, right? 200 volt and 200 ohm. Yes, 200 ohm, 200 volt, both. 200 square plus Xc 106.15 minus XL 31.4 whole square. Z is equal to, okay, what I can do now, Z equal to, yeah, 106.15 minus 31.4. 31.4 is equal to 74.75. 200 square plus 74.75 whole square. Z equal to root of 40,000 plus, is it right? 106, yeah, it is almost right. 106.15 minus 31.4 is equal to 74.75. 74.75 into 74.75, that comes to 5,587.6. 5,587.56. I'll write it as 6. So that is 40 plus 40,000. Z equal to this plus 40,000 plus 40,000 200 square. Yes, that is equal to square root. Square root, yeah, square root is 213.5 ohm. Z is 213.5 ohm. Yes. 40,000 plus 558, 5,557. 74.75 into 74.75. This one plus 40,000 is equal to square root 213.5 ohm Z. Okay, Z is obtained. Next, so one more answer. Impedance is over. Calculate inductive reactance, capacitive reactance, total impedance over. So we will take one by one. This is over, impedance is over. Current in the circuit, I is equal to V by Z. So since we are using V as RMS, this is RMS, this is also RMS. IRMS is VRMS by Z, 213.5. That is equal to 200 divided by 213.5. 200 divided by 213.5. That is equal to 0.936 or 0.937 I can write. 0.9367, so 7 ampere. This is IRMS. What is I peak? IM peak value, not IM maximum. At that moment, what is the peak value? If it is asked, of course it is not asked, it is asked only in the current in the circuit. That means RMS current, if they don't mention. If they ask you what is the maximum current at that moment, the peak value of current, it is not the highest peak value. Surely it is not the highest peak value. IM is equal to, you know that IRMS is equal to IM by root 2, right? So what is IM? IRMS into root 2, that is equal to 0.937 into 1.414 ampere. Root 2 into 1.414, that is root 2, that is equal to 1.3245. 1.325 I'll write ampere. This is the peak value of current at that moment. What else you have to calculate? Voltages across L, C and R. All RMS we will calculate. This is not asked actually. All RMS. Voltage across L. I don't write RMS. I write simply VL. VL RMS. Or if needed, we will write VL RMS. So what is the voltage across L RMS? It is I into IRMS into XL. That is equal to, what is IRMS? IRMS is this one, 0.937 ampere into XL. What is XL? 31.4. 31.4. That is equal to 0.937 ampere IRMS into 31.4. 29.42. 29.42 volt. This one. What is VC RMS? IRMS into the reactive capacitive reactance, 0.937 into capacitive reactance is 106.15. 106.15 is equal to, so what is the answer? 0.937 into 106.15. 99.46 volt. 99.46 volt. And what is the voltage across R? Is IRMS into R. So this is RMS. R, that is IRMS is 0.937 into resistance. Resistance is 200 ohm. 200, that is equal to 0.937 into 200, that is equal to 187.4. Now I want to mention one thing here, right? So 0.937, yeah, it is almost nearer to 200. Yes, 187.4 volt. One thing I want to mention here, that is at these voltages, voltage across R, voltage across C, voltage across L, will you get 200 volt supplied voltage? You will get more than that. 187 plus 99, that itself makes more than 200, right? Say this is almost 100 and this is 30. 100 plus 30, 130 plus 180. It is almost 310. But supplied voltage is 200. Why? Because it is not the addition of voltages. Because all the voltages are not in phase, you know it. They are in different phases. Voltage across resistor is 90 degree, it is in phase with current. Across inductor and capacitor, they are out of phase at plus 90 and minus 90. It's totally 180 degree out of phase. So that is a way in which we find out, right, the resultant voltage. Sir, then how can you get the resultant voltage 200 volt? You can use this formula. Just simply for reference, I can do it like this. The supplied voltage Vrms is equal to root of, in between the derivation I have mentioned this, that this is also important, Vr squared plus all RMS, Vrms, Vc minus Vl whole square. Just keep on multiplying this by I. Where is that formula? Z, I into Z, I into R squared, I squared into R squared, I into XSC minus XL whole squared. You will get the same answer, this one. So shall we get 200? You will get approximately 200 because you have mentioned you have approximated here all the answers. So we will check it. Root of voltage across R square, that is 187.4 square, plus this difference Vc minus Vl whole square. What is Vc minus Vl whole square? This one, 99.46 minus 29.42 is equal to 70.04, almost 70.04 whole square. That is equal to, so what you will get, you have to write this, square root of 187.4 whole square, 187.4 into 187.4, that is equal to 35,118.76 plus square of this 70.04 whole square, 70.04 into 70.04, that comes to 4,905.6, 4,905.6, yes, plus 4,905.6 plus, okay, 35,118.76 is equal to square root. It is 200.06. You get it? So it is not the direct addition. That's why I have taken it. So voltage across L, C, R, when they are simply added as scalars, you don't get the answer. You have to use the phasors, which represent the phase difference. Okay, so it is not finished. Problem is very long. Voltage across L and C is over. Power factor, phase difference. Yeah. Shall I rub this? Because that board is not enough. Power factor and phase difference. Phase difference, I think you can do that together. But we need XC, XL and all. XC is needed. XC, I will write it here so that it is needed now. XL is over here. XL is how much? 31.4. XL is 31.40. XL is 31.4 ohm. XC is how much did you get? It is here, 106.15 ohm. What else we have got? Z is equal to 213.5 ohm. Okay. IRMS is equal to 937 amperes. Peak value not needed. Voltage across L and C, I think it is not needed in the further calculations. Yes, this much is enough for me. So here I have already concluded that XC is greater than XL, so current should lead. Capacitive reactance is more. So what you have to find out now? Cos phi. Cos phi is equal to R by Z. Cos phi is equal to R. R is 200 ohm by Z. Z is 213.5, right? Here we have substituted as 200 divided by 213.5. 200 divided by 213.5 is equal to 0.9367 or 0.9368. 0.9368. Yes, cos phi. This is power factor. So therefore, power factor is equal to 0.9368. Cos phi itself is power factor. What is phase angle? Phase angle here, phi is equal to cos inverse of 0.9368. Yeah, phi is equal to, go for the class table, 0.9368. So you have to take the cos inverse of 0.9368, natural cosines 0.9368. You have to search for that number, natural cosines 0.9368, it should be in the beginning. Cos 0 is 1, right? Cos 9368, yeah, 9368, 94. Cos value goes on decreasing, so we have 9373. We have 9367. That is enough, I think. It is 20 degrees and 20.5 degrees. 20 degrees 30 minutes, 20.5 degrees, 0.9368. That is enough. 0.9367 we have. So phi is equal to 20.5 degrees. So which is leading current? Current leads EMF by 20.5 degrees. Okay, that is over. So what is the power factor? What is the phase difference? That is over. And even the which will lead, that is over. Then resonant frequency, definitely resonant frequency will be greater than 50 Hz. Why? Because we are at a position which is lesser than the resonant frequency. So omega naught, shall I rub this? Yeah, I can rub this. Omega naught is equal to 1 by 2 pi root LC. 1 by root LC. Or you can write nu naught, that is better. Nu naught is equal to 1 by 2 pi root LC. 1 by 2 into 3.14 into root of LC, inductance and capacitance. Inductance, self-inductance of the inductor 100 millihenry, 100 into 10 to the power minus 3 into 30 microfarad, 30 micro. Nu naught is equal to 1 by 6.28, this one, into root of, here you have 2 zeros, here you have 1 zero, gone, correct? 100, 10 to the power 2, 10 to the power 3, minus 3, gone. 3 into 10 to the power minus 6, square root of, I will take 10 to the power minus 3 outside. Square root of 10 to the power minus 6 is 10 to the power minus 6 to the power half. So that is 10 to the power minus 3, root of 3, 1.732. Nu naught is equal to, okay, into 10 to the power 3, right? This comes to the numerator, and the rest of the things 1 by 6.28. 1 divided by 6.28, yes, is equal to divided by 1.732, because square root of 3 is 1.732. 0.0919, 0.0919 into 10 to the power 3 Hertz. That is equal to how much? 10 to the power 3 means 1, 2, 3, 91.9 Hertz. This is the resonant frequency, but we are at lesser frequency, 50 Hertz, which is lesser than the resonant frequency. That's why we got Xc greater than XL. Okay, resonance frequency, power dissipated is equal to Vrms into Irms into cos phi. Directly you can write it, Vrms into Irms into cos phi. Vrms is 200. What is Irms? Irms is current is 0.937, and cos phi is already here. Cos phi is 0.9368. 0.9368. So that is equal to power dissipated, average power dissipated, it is 200 into 9.937 into 0.9368, 0.9368. That is equal to 175.556, 175.6, I'll write, watt. This is the power dissipated, average power dissipated. Quality factor is equal to you can do it like this. See, if you know the inductance, capacitance values, you can directly find out the quality factor. Quality factor is resonance frequency by bandwidth, but we don't know the bandwidth. Or you can use omega naught L by R, right? Here you can do one thing. Instead of you see omega naught we have found out, right? Where is the value of omega naught? Omega naught, nu naught we have found out. 2 pi, multiply by 2 pi, you will get 91.9 hertz. Okay, we can do that like that. 2 pi nu naught L divided by R. So that is equal to, this is 314, you know. 2 into 3.14 into 50. Not 50. You have to write nu naught, sorry. It should be nu naught, it should be not 50. Resonant frequency only. So quality factor is equal to 2 pi nu naught, 2 into 3.14 into resonant frequency is this one, 91.9 hertz, into self-inductance of the coil. Self-inductance is 100 millihenry, 100 milli divided by R, resistance. Resistance is 200. Okay, I think I can divide this and make it very clear. Yeah, what is the answer? That is equal to 3.14 into 91.9 is equal to 288.56. 288.56 into 10 to the power minus 3. So quality factor is 0.288. So shall I write it as 0.29 or 0.288? No unit for quality factor because it is frequency by frequency, resistance by resistance. Okay, so 0.288. Or you can do it like this also. See, I will give you another method of finding the quality factor. It is like this. Quality factor is omega naught L by R. So Q is equal to omega naught L by R. That is equal to omega naught is 1 by omega is 1 by 2 pi root LC. Another formula for omega naught. We have omega naught L 2 pi nu naught L, right? Resonant frequency formula. See, this multiply and divide. Nu naught is equal to 1 by 2 pi root LC. What is, if you bring this 2 pi here, omega naught is equal to 1 by root LC, right? You have one more formula. Here we have used 2 pi nu naught, that's all. 1 by root LC formula we will use. L by R, omega naught, 1 by root LC. Okay? Now write this L as root of L square. 1 by root LC, root of L square by R. So what you will get? That is equal to, all the things in the root, write it together. L square by LC, 1 by R. Am I right? So I have substituted omega naught is equal to 1 by root LC, L by R as it is. Put this as root L square by LC. 1 L gets cancelled. Root of L by C, 1 by R. That is equal to 1 by R, root of L by C. So will we, shall we put that those values and let us check whether you get the same answer or not. Quality factor Q is equal to, I'll rub this. Okay. Quality factor Q is equal to 1 by R, root of L by C. 1 by 200, root of 100 millihenry, 30 microfarad. Now I can remember all the values after working out so much. Okay, quality factor is equal to 1 by 200, root of 10 gone, 30 by 3, 10 by 3. I can calculate 1 by 3 into 10 to the power, this one, plus 6 here. Here plus 6, plus 7, 7 minus 4, 3, 4. Did you get that? 10 to the minus 6 plus 6, 7 here, 1 here, 7, 7 minus 3, 4. That is equal to, quality factor is equal to, this is 100 after getting square root. 10 to the power 4 square root is 10 to the power 2. So 100 by 200 by 1 by root 3. This is 1 by 2. 1 by 2 root 3. That is equal to 1 by 2 root 3. That is 1 by 2, that is 0.5 divided by 1.732. How much you get? 0.28. Yeah, exactly the same value. 0.288. Yes, 0.288. Same quality factor. I think this is a better formula because you will use all the data here instead of using all the values that we have found out. So quality factor can be found out in that form also. Now if you are asked to find out what is the bandwidth, what is bandwidth? That is not included here. So that is the last one. Power factor, power dissipated, quality factor. What is the bandwidth if it is asked? We have to go for the original formula once again. Resonant frequency by bandwidth is quality factor. Omega naught by delta omega, 2 delta omega. So what is 2 delta omega? 2 delta omega itself is bandwidth, remember, is equal to omega naught by quality factor. 2 delta omega, that is bandwidth, is equal to 2 delta omega is equal to omega naught. What is resonant frequency? 2 pi nu naught. Here we have substituted, right? 2 pi nu naught. 2, so omega naught by q, 2 pi nu naught by q, correct? 2 pi, yeah, quality factor is 2 pi nu naught by q. Bandwidth is equal to 2 pi nu naught is okay, 2 pi 91.9, right, nu naught by q. Quality factor we have calculated 0.288. 0.288 bandwidth is equal to, that is a range of frequencies across which current is at least between maximum or maximum by root 2. 2 into 3.14 into 91.9 is equal to, divided by 0.288. 2003.9, I doubt. Bandwidth 2003.9, okay, 9 hertz. 1 minute, I will check it. Resonant frequency by bandwidth. Bandwidth is the resonant frequency by quality factor, because quality factor is resonant frequency by bandwidth. So bandwidth is 2 delta omega, omega naught by q, omega naught is 2 pi nu naught. Resonant frequency is 91.9 hertz, so 2 pi nu naught. I think it's correct, right? 2 into 3.14 into 91.9 divided by 0.288. 2003.9 hertz. So that is bandwidth. So this is how we can calculate all the values, right? We have calculated everything here. Now we will move on to the next problems. Okay. Second one. A 100 ohm resistor is connected to a 220 volt 50 hertz AC supply. Okay. 100 ohm resistor, only resistor is connected. What is the RMS value of current in the circuit? Okay. What is that given value 220 volt? It is also RMS. It is also RMS. Okay, here you have answers. Can you see that? Yeah, I don't know whether you can see that or not. Okay, but we will calculate it. I have changed the color, but I don't know. I didn't think whether it is visible or not. Yeah, a little bit visible. Right. Rub that also. What is the RMS value of current in this? IRMS equal to VRMS by Z. You know it. Okay. IRMS is equal to VRMS divided by Z. But here we have only one component, that is resistor. So 220 divided by 100. Correct? So it is 2.2 ampere. This is over. I think if you can see that, it is 2.2 amperes. What is the RMS value of current in the circuit? Is it not focused? I doubt. Yeah, it is focused. 2.2 amperes. Then, what is the net power consumed over a full cycle? Since it is resistive, there is power consumed. Power consumed, average power per cycle, VRMS, IRMS into cos phi. You know that phi is 0, cos phi is 1. Because in a purely resistive circuit, power factor cos phi is 1. Phase difference is 0. So what is the answer? Is equal to VRMS 220, IRMS 2.2, cos phi 1, that is equal to, now onwards you have the answers, so you can check whether your problem solution is correct or not. 220 into 2.2, that is equal to 484 watt, yes, 484 watt. Okay, what else? The peak voltage of an AC supply is 300 volt. What is the RMS voltage? Of course, these are the small problems. Peak voltage of an AC supply is 300 volt. What is the RMS voltage? Yeah, there is a different problem actually. Peak voltage of an AC supply is 300 volt. RMS is VRMS is peak by root 2, 300 divided by 1.414, that is equal to 212.16. 212.16. Okay, what else? Then yeah, the RMS value of a current in an AC circuit is 10 ampere. What is the peak value? I current, right? IRMS is equal to Im by root 2. That implies peak value Im is equal to IRMS into root 2. RMS value is 10 into 1.414, that is 14.14 ampere. Is it correct? 14.14, 212.16, everything is correct. So here I have not written unit. Yeah, second one is over. Third one. Yes. A 60 microfarad capacitor is connected to a 110 volt 60 hertz AC supply. Determine the RMS value of current in the circuit. What is the net power absorbed per cycle? Do we have time? Yes, we have enough time. We will do that. A 60 microfarad capacitor is connected to a 110 volt 60 hertz AC supply. Only capacitor is connected. So there is XC, there is no XL, there is no R. Leave all those terms. Well, use all the formulas of resonance, but don't use XL and R. That's all. Simply you can stick on to the same formula. Okay, what is determine the RMS value of current? If you want to know what is IRMS, VRMS divided by Z. But here VRMS divided by XC only, because there is no Z equal to root of R square plus XC minus XL whole square. Here R is 0, XL is 0. So root of XC square only. Root of XC square is XC only. So VRMS by XC. What is XC? XC is 1 by 2 pi nu C. Shall we go on writing the formula here only? VRMS divided by 1 by 2 pi nu C. It is not at resonance. We don't know whether it is at resonance or not. Whatever the frequency is supplied, we will use it. 1 by omega C, so 1 by 2 pi nu C, 2 pi nu C into VRMS. So IRMS is equal to 2 pi nu 60 hertz C, a 60 microfarad capacitor. 60 microfarad capacitor. 2 pi nu C. 2 pi nu C. VRMS connected to 110 volt. So what is the value of current in the circuit? IRMS is equal to, simply go on multiplying, 2 into 3.14 into 60 into 60, 3600 into 110. Yeah, into 10 to the minus 6 you have. Okay, we will write the number that I get in the calculator. 24868 24868 880 2486880 into 10 to the minus 6. That is equal to 1. So 1, 2, 3, 4, 5, 6. 2.487 I'll write amperes. Is it? 2.49 they have written. Yeah. What is the net power absorbed per cycle? Since it is capacitive, right? Since it is capacitive circuit, current is wattless, you know this. Capacitive circuit, only capacitive. Phi is 90 degrees, pi by 2. Current leads the voltage by 90 degrees. Current leads the voltage. So power dissipated per cycle is VRMS into IRMS into cos phi. This comes to 0. So total 0 watt. Yes, shall we? Well, we can move on to one more problem. Fourth one. Obtain the resonant frequency omega r of a series LCR circuit with L, C and R. What is the Q value of this circuit? Yes. Now what we are doing in the remaining problems are the part of the first problem, that's all. But we have some tricks in some problems. We will have some tricks. We are going to solve 21 problems in the same chapter, one by one. Obtain the resonant frequency omega R of a series resonant circuit. Omega R, 1 by root LC. It is not nu naught we are finding. They are asking you to find out omega R. Okay, you can find nu R also. 1 by root LC. L is 2 Henry, C is how much? 32 microfarad. Oh, this can be done by hand, not through calculator, because you get 64 here. Omega R is equal to 1 by root of 64 into 10 to the power minus 6. That is equal to 1 by 8 into 10 to the power minus 3. Omega R is equal to, you bring this here, 1000. 10 to the power minus 3 becomes 1000 by 8. That is equal to 8 ones are 2 remaining, 8 twos are 4 remaining, and 5. 125 hertz. You can write this one also as hertz or radian per second. Hertz. Okay. Now, if you want to have nu R, then you have to go for nu R, resonant frequency nu naught, 1 by 2 pi root LC. Right? That's the difference. 2 pi nu naught is equal to 1 by root LC. So you have to divide this. 1 by root LC, however, we have the ready answer, 125 divided by, oh, the same thing. Okay, 125 divided by 2 pi. 2 into 3.14, that is equal to 6.28. 125 by 6.28, 25 divided by 6.28, 19.9 hertz. Answer for this is also hertz, because here you have only 2 pi extra, that's all, nothing else, right? So 2 pi is a constant, so you need not worry about the answer. So unit, same hertz, 19.9 hertz. What else you have? What is the Q value of the circuit? Quality factor is resonant frequency by bandwidth, but we don't have bandwidth. You can have, write this, omega naught L by R. At resonance, what is omega naught L? So that can be written as 1 by, of course, I will do it once again. I did it in the previous problem. Now again I will do. Just keep on doing it like this. So what is omega naught? 1 by root LC, L by R. Because simply biting the formula is not good. You will have to write it and write it, and then you have to learn it. Then it will be a permanent print in your brain. So that is equal to root of L square by LC, 1 by R. So 1 by R into root of L by C. That is equal to 1 by R, 1 by 10, root of L, 2 Henry, by C, 32 microfarad. I think this can also be done without calculator. 1 by 10, this is 16, that is 1 by 4, correct? Into 10 to the power minus 3, because this is square root is 10 to the minus 3. So this is 16, okay, 1 by 4. This is 10 to the power minus 2, am I right? 10 to the power minus 2 comes to 10 to the power 2, 100. 10 to the power 1, 10 to the power minus 3, 10 to the power minus 2. Bring it to the numerator, 100, 10 to the power 2. By 4, that is 25. No unit, quality factor is 25. Okay, so that is the problem. And fifth problem, we will go to the next video. Yeah, it's a long problem, so that time won't be enough for me. So thanks for watching the class. We will continue it in the next video. We will have to complete 21 problems. Just we are in the fifth problem. Thanks for watching the class. Of course, you can keep on working it out yourself. You have got the idea now, but problems are very nice and very easy to understand. Thank you.